Welcome back to RaWMachines, the journey to discover the most impressive processes from around the world. Today, join me as we go behind the scenes of the maritime industry, where massive vessels are built, upgraded, and brought back to life from heavy damage. Hot steel, welding sparks, and mechanical wonders are waiting for you. Let's get started. These documentary frames capture the birth of the BUAP Union, the largest sail training vessel in Latin America, constructed at the Sima State Shipyard of the Peruvian Navy. The shipbuilding process began with an advanced modular method. Rather than erecting the ship as a single unified block, engineers divided it into 38 distinct structural sections. Each module acted as an independent puzzle piece, fabricated simultaneously across multiple areas of the shipyard. As the first 29 modules were completed, including the living quarters, engine room, and double-bottom structures, the ship's form gradually emerged, much like a colossal painting being assembled piece by piece toward completion. Inside each module, every stage achieved near absolute precision. Steel plates were cut using CNC technology. Welds adhered to rigorous standards, and every detail was meticulously aligned so that during assembly, everything fit together as if they had never been apart. As the modules were moved into the dry dock, heavy lift cranes began their dance. Steel blocks weighing hundreds of tons were hoisted, slowly rotated in midair, and placed precisely into their predetermined positions. The double bottom was installed first, serving as the foundation for the entire vessel. Beyond providing watertight integrity, it enhances structural durability and creates space for critical systems. From that foundation, layer after layer of the structure continued to rise, with modules connecting in sequence until the hull neared completion. Despite being a sailing ship, the BAP Union still requires a modern propulsion system. A massive diesel engine and generator set arrived via oversized load transport. Supported by a specialized rigging system, a crane hoisted the entire engine block, lowered it through the deck openings, and seated it precisely onto the mounting bed deep within the hull. This is a one-shot operation that must be completed before the hull is sealed shut. As soon as the engine core was seated, steel deck plates were immediately moved in to lock down the machinery space. Welding sparks showered down like rain from arc welders, reflecting the urgent and grueling pace of the work. The entire structure was welded seamlessly into the ship's frames, transforming the hull into a rigid box girder capable of withstanding massive torsional moments in the open ocean. From the keel laying in 2012 to the completion of the primary hull in 2014, it was a long journey of sweat, hot steel, and relentless welding sparks. But the Sima shipyard wasn't just joining steel plates. They were creating a colossal structure, rigid enough to support 4 towering masts and endure the most violent storms on the ocean. The birth of the BAP Union does not just mark a new training ship, it is a powerful declaration of heavy industrial mastery and this South American nation's ambition for maritime self-sufficiency. Next, we move to Zamil shipyards, a hub where the power of modern mechanics meets peak maritime engineering. Here, every detail, no matter how small, is handled with near absolute precision. Every worker performs a distinct role, acting as vital links within a colossal industrial machine. From cleaning the hull and stripping away stubborn barnacles to the fine-tuning of complex propulsion systems, everything follows a rigorous, synchronized, and step-by-step process. Amidst the grueling environment of the shipyard, discipline and focus are maintained at the highest levels. This is what creates the definitive edge. Every vessel leaving Zamil shipyards is not merely restored, but elevated to meet the most stringent standards of engineering, safety, and offshore reliability. In Papenburg, Germany, one of the most luxurious icons of the maritime travel industry is taking shape: the spirit of discovery. Once the blueprints are finalized, the sparks begin to fly. Colossal steel plates are precision cut by lasers and joined by automated robotic welding systems. This is the foundational phase, executed under the rigorous supervision of an expert engineering team. The true grandeur is revealed during the assembly stage. Like a giant jigsaw puzzle, hull sections weighing hundreds of tons are hoisted by cranes and fitted together with absolute precision. From the proud bow to the superstructure, the vessel gradually rises within the world's largest covered shipbuilding hall. Next comes the completion of the ship's internal power. The massive propeller systems and drive shafts are meticulously installed, parallel to the application of protective hull coatings. Inside, skilled crews work through the night, installing thousands of meters of cabling and interior paneling to transform the cold steel mass into a floating five-star hotel. And then, the most anticipated moment arrives: the float-out. Water is pumped into the dry dock, releasing the spirit of discovery from the ground. The massive vessel glides gently, touching the water for the first time, to the immense pride of thousands of shipyard workers. Under the nightlights and assisted by tugboats, the mega cruiser moves out onto the Ems River to begin its sea trials. An engineering masterpiece is complete, ready to provide the ultimate discovery experience for passengers worldwide. This is not just a ship. It is a testament to human ingenuity in conquering the greatest challenges of modern maritime engineering. At the Lisnave shipyard, hypogloid vessels undergo a very specialized transformation, the replacement of the bulbous bow, the critical component that determines how a ship cuts through the water. The old bow is sliced away, exposing the internal steel framework of the hull. After a rigorous process of inspection and structural reinforcement, a newly engineered bow with a superior hydrodynamic profile is moved into position for installation. Once the process is complete, the ship's overall appearance remains largely unchanged. Yet, beneath that exterior, operational efficiency has been significantly boosted. Fuel consumption is reduced, stability is enhanced, and the environmental footprint is minimized. A seemingly small modification that makes a massive difference across thousands of nautical miles. At Avitan Shipyard, the journey of vessel maintenance begins with a step that is seemingly simple yet absolutely decisive: docking the ship. As the water gradually recedes, layers of long-term marine growth are rapidly stripped away by high-pressure washing systems, exposing the ship's original steel hull. The anchoring system and anchor chains, the vessel's parking brakes, are also lowered. These colossal chain links are laid out across the dock floor for wear inspection and cleaning. This is a critical step to ensure the ship can drop anchor safely in any weather condition. Next is the surface treatment and coating phase. Workers on specialized man lifts apply primers and protective coatings to the bottom and top sides of the hull. Simultaneously, experts from M/Maritime personally inspect every section of the hull, ensuring that not a single crack or structural defect is overlooked. Inside the vast cargo holds, cleaning and repainting are also underway to prevent corrosion caused by cargo friction and the marine environment. On the exterior, the anchor chain links are color-coded according to international standards, allowing the crew to easily monitor the depth during anchoring operations. The vessel's name, AVRA.GR, along with the company logo, is repainted with sharp clarity, finalizing its new appearance. The technical focus then shifts to the propeller and rudder systems, the core propulsion components. These are meticulously inspected, reinforced, and polished to optimize the vessel's operational efficiency and navigational handling. As night falls, the work continues. The inspection team, outfitted in white protective gear, conducts a final sweep of the deck and hatch covers, ensuring every detail meets international maritime safety standards. With all stages complete, water is pumped back into the dry dock, lifting the vessel once more. The AVRA.GR departs the Neo-Orion shipyard with a refreshed appearance and its operational capacity restored to near perfection. This is more than just a maintenance routine. It is a testament to the vision of M/Maritime, protecting strategic assets and keeping the flow of global trade smooth and secure. In Saint-Nazaire, one of the most ambitious maritime projects in history is entering its final stretch, the construction of the MS.C. Meraviglia. This is not merely a ship, it is a floating city, engineered using the most advanced modular construction technology. The entire hull is a fusion of megablocks weighing thousands of tons, where a margin of error of even a few millimeters across a structure over 300 meters long simply cannot exist. The greatest challenge lies in integrating millions of technical components into a colossal steel framework. The assembly process demands near-perfect coordination between ultra-heavy crane systems and the engineering teams. Each module lowered into the dry dock is not just a structural piece, it is a vital link in the complex operational system of this new generation of supercruisers. Beyond the staggering figures of dimensions and tonnage, this project is a clear testament to heavy industrial logistics management. From steel surface treatment and tolerance control to the installation of complex superstructures, every stage adheres to the most stringent technical standards of 21st century shipbuilding. At the Caspian Maritime Hub, Baku Shipyard is tackling a formidable challenge of mechanics and gravity. The subject of this project is the Vesalius, a massive steel entity that must be relocated with absolute precision. The process begins with the configuration of self-propelled modular transporters, SPMTs. Engineers must calculate the center of gravity with extreme accuracy to ensure this colossal steel mass is lifted in perfect balance. Once everything is set, the Vesalius begins its overland walk. Under the command of an expert team, the vessel moves at a crawl, centimeter by centimeter. The hydraulic pressure across the hundreds of wheels is constantly adjusted to compensate for even the slightest unevenness in the ground, maintaining the hull in a state of absolute stability. After hours of intense labor, the Vesalius is positioned perfectly within the dock. The lifting system slowly lowers, seating the ship onto fixed keel blocks. The overland transport operation is a resounding success, clearing the way for the launching phase and sea trials in the Caspian Sea. Grounding is a nightmare for any vessel. When the hull strikes the seabed, it leaves behind severe wounds across the steel plating. To solve the problem, a dedicated team of engineers, welders, and maritime repair specialists has been mobilized. Each with a specific mission, they work tirelessly to restore the ship to its original operational state. Every damaged steel plate is cut away. New hull sections are precision fabricated and then welded back with absolute meticulousness. This process demands more than just physical strength. It requires a perfect harmony between experience and technology. And then, after all the relentless effort, the ship is ready to return to the high seas. This is the clearest proof that, no matter how great the damage, everything can be mended if we refuse to give up on it. After about 8 months of tireless filming and editing, CMR Studios has brought this film to life. First and foremost, I would like to extend my deepest gratitude to them. At the shipyard, the single-hull to double-hull conversion project for Maritrans's Ocean States program is underway. This is more than just an engineering project. It is a strategic mission to meet the stringent maritime safety and environmental protection regulations of the Oil Pollution Act of 1990. The process begins with the complete dismantling of the old steel structure. Thousands of tons of material are stripped away, exposing the vessel's original skeletal framework. Now, the assembly phase begins. The new double-hull modules are hoisted by cranes, maneuvered, and lowered with near absolute precision. Welding sparks fly relentlessly, day and night, fusing the second protective layer to the main hull, creating an optimized leak-proof system. The final stretch begins with the application of protective coatings and ultimate quality inspections. Water is gradually pumped back into the dock, as the barge slowly gains buoyancy and lifts off the fixed keel blocks. It is more than just a technical moment. It is the milestone of months of intense, high-precision construction. After 8 months of continuous work, the vessel designated M214 leaves the yard with a completely new identity. It is not only stronger and safer, but also ready for long voyages under the highest environmental protection and standards. This is not merely an upgrade, it is an evolution where engineering and responsibility sail side by side across the ocean. In the North Sea, one of the most significant salvage challenges in modern maritime history has been executed: the clearing of the Baltic ACE wreck. This was not merely about moving a 13,000-ton object. It was a critical mission to protect the ecosystem and restore the economic lifeline of the port of Rotterdam. The first stage was an environmental rescue mission. Because the oil in the tanks had solidified in the cold depths, engineers employed the hot tap method, using heating units to liquefy the oil underwater before pumping it out. Over 456,000 liters of oil were successfully recovered, eliminating a massive pollution risk. Moving into 2015, the true challenge began. Deep surveys revealed that the ship's structure was more heavily damaged than expected, forcing the technical team to revise the plan from 6 sections to 8. A diamond wire cutting system stretching 120 meters was deployed. To combat the heavy ocean swells, heave compensation technology was integrated, ensuring the cutting wire maintained absolute stability during the surgical dissection of the massive steel hull. One by one, sections of the ship were hoisted from the water. The bow section alone weighed 1,500 tons, making it one of the heaviest blocks ever salvaged in the region. A coordinated effort involving 18 specialized vessels and 150 experts created a relentless working rhythm. The remaining hull fragments, along with hundreds of mangled vehicles, were meticulously gathered using specialized heavy-duty grapples. Finally, after the wreckage was transported to shore for sustainable recycling, the entire seabed area was laser scanned to ensure not a single piece of debris remained. The project was completed 2 months ahead of schedule, with 13,000 tons of steel fully recycled. This stands as a powerful testament to human capability in overcoming maritime disasters through intellect and cutting-edge technology. So, we have just completed a journey, traveling through various shipyards, diverse projects, and vastly different contexts. in each location, we've only seen a small fraction of the bigger picture. In some places, it's the process of building from the ground up, where everything starts as scattered steel plates before gradually forming a complete structure. In others, it's the meticulous work of maintenance and repair. These differences might make it seem like each location tells a unique story, but in reality, the way humanity solves problems across all these cases is remarkably similar. First is the method of deconstruction. No one tries to handle a ship as a single, monolithic block. Everything is broken down into parts, systems, and individual work steps. This doesn't just make the task easier, it ensures better control. Second is the reliance on process over intuition. This type of work leaves no room for estimation or vague, experience-based guesses. Every step has a standard, a sequence, and a verification method. More importantly, these steps are repeated countless times across many different projects to ensure that the results remain consistent. Furthermore, one point is clear throughout the entire journey: improvement almost never stops. It isn't always about radical shifts, but often very small things. Yet, it is these small changes, when applied continuously and at scale, that create a significant difference over time. When you piece all of this together, you can see that the maritime industry isn't a place of flashy moments, but a place of stability. The goal isn't to do something remarkable once, but to ensure everything works correctly many times over, under many different conditions. And that is the crux of it. A ship may look incredibly complex, but what determines whether it functions well or not lies in the basics. These things aren't grand, but without them, the entire system cannot operate safely. In other words, the final result, the ship's heading out to sea, is just the visible part. The more important part lies behind the scenes. The way humans organize work, build processes, and control quality at every single step. Thank you for listening to the end of our story. If you enjoy videos like this, please like, share, and subscribe to the channel so you don't miss our upcoming stories. RaWMachines says goodbye, and we'll see you next time.